For this notebook entry, you'll need your notebook, the divisibility rules page, the prime factorization page, glue, and scissors. On the prime factorization page, we're going to cut off the very bottom row of numbers. These were included as an option for additional practice, but you'll be practicing this using something different. Trim around the outside along the dotted lines for both pages. Open to the next blank page in your notebook. Glue the divisibility rules page at least 4 lines down from the top. The title of this entry is Prime Factorization. In the top right corner, add the standard title 7NS1. This is a 7th grade standard. It is the first standard in the number system category. The learning goal is, I can find the prime factorization of a number and write it in exponential notation. A number is divisible by another if, after division, the remainder is 0. A factor is a number that divides into a whole number with a remainder of 0. For example, 8 is divisible by 2 and 4 and 8, meaning 2, 4, and 8 are all factors of 8. The divisibility rules can help you when you are trying to find the factors of a number. They will help you to quickly find what numbers you can divide by. A number is divisible by 2 if the digit in the ones place is even. This means the ending number must be 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of the digits is divisible by 3. A number is divisible by 4 if after you half the number it is even. A number is divisible by 5 if the digit at the end is either 0 or 5. A number is divisible by 6 if it is divisible by both 2 and 3. A number is divisible by 9 if the sum of the digits is divisible by 9. A number is divisible by 10 if the number ends in 0. We're going to complete this chart and check for the divisibility by these numbers for the given examples. Put a check mark if it is divisible by that number or an X if it is not. I'll do the first example with you. We're going to check if 26 is divisible by 2, 3, 4, 5, 6, 9, and 10. The last digit in 26 is 6. 6 is an even number, so yes, this is divisible by 2. I'll place a check mark in the 2 column by the number 26. Next, let's check if it's divisible by 3. First, we need to add each digit. 26 has a 2 and a 6. We'll add 2 plus 6 to get the number 8. Is 8 divisible by 3? 3 cannot go into 8 evenly, so 26 is not divisible by 3. I'll mark this with an X. We'll check if it's divisible by 4 by dividing 26 in half. That's 13. Is 13 an even number? No, so 26 is not divisible by 4. An alternative way to think about divisibility by 4 is to ask yourself, can I divide this number in half 2 times and still have a whole number? To check if it's divisible by 5, I'll just look at the last digit again, which is a 6. Is that a 5 or a 0? No. 26 is not divisible by 5. To check if it's divisible by 6, I need to check if it's divisible by both 2 and 3. I'll just look back at the chart because I already checked if it was divisible by these numbers. I see that it is divisible by 2, but it is not divisible by 3. It has to be both, so 26 is not divisible by 6. To check if it's divisible by 9, I need to add the digits again. I'll add 2 plus 6, and that equals 8. Is 8 divisible by 9? 8 cannot go into 9 evenly, so no, 26 is not divisible by 9. And last, to check if it's divisible by 10, I'll check to see if the last digit is 0. It's not, it's 6, so 26 is not divisible by 10. If a number fails all of these divisibility tests, then it is highly likely that the number is a prime number. You need to finish filling out the rest of this chart. Pause the video, grab a whiteboard, marker, and eraser pad, and try out these examples. Once you're done, continue with the video. Now it's time to take the prime factorization paper. We're going to make a fold along the left edge to create a vertical flap as shown. We'll put glue onto the flap we just created and glue this along the far left edge of the paper. Try to get it to not cover up any of the divisibility paper underneath. This will create a foldable page that lets you access your divisibility notes underneath. A prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. A composite number is a whole number greater than 1 that has more than two factors. We're going to identify prime and composite numbers up to the number 48. Many prime numbers occur within this range, and they become increasingly rarer as numbers get larger. There may appear to be a pattern in the set we'll be checking, but there's actually no proven pattern for when prime numbers will occur. It's a mathematical mystery. First, we'll circle the number 2. 2 is a prime number because it only has two factors, 1 and 2. 1 times 2 is 2, and that's the only way to multiply to get 2. We'll go through and cross out all the multiples of 2 by counting by 2's. 4, 6, 8, 10, 12, and so on. Each of these numbers are not prime. They are composite because they are divisible by 1 and itself, and at least the number 2 and some other number. Now we'll circle the next available number after 2, which is 3. 3 is a prime number because it only has two factors, 1 and 3. We'll cross out all the multiples of 3 by counting by 3's. 6, 9, 12, 15, and so on. If you can't count by 3's, then just count 1, 2, 3. 1, 2, 3. All of these numbers will be composite because they are divisible by 1 in itself and 3 and some other number. We'll circle the next available number again, which is 5. 5 is a prime number. Now we'll cross off all the multiples of 5 by counting by 5's. 10, 15, 20, 25, and so on. Do the same for the next prime number 7. Continue in this manner until all numbers are either circled or crossed out. Here is a finished product. Check to make sure yours matches. Prime factorization is expressing a composite number as the product of prime numbers. A tool to break down numbers is called the factor tree. I will do two examples with you. The first number is 54. I know that 6 times 9 is 54 because of multiplication facts, but I also could have checked using the divisibility rules. 6 can be broken down further because it's still a composite number. I know that 2 times 3 is 6. I need to break down the 9 as well. I know that 3 times 3 is 9. I can't break these down any further because 2 and 3 are both prime numbers. If I kept going, I'd just be writing 1 times 2 or 1 times 3 over and over and over. I stop when the number is prime. I'll circle the 2, the 3, and the other 3. 2 times 3 times 3 times 3 is 54. You can check it on a calculator if you like. I'm not done yet because I need to write this using exponents if needed. I can simplify 3 times 3 times 3 as 3 cubed or 3 with an exponent of 3, which means the same thing. So my final simplified answer is 2 times 3 to the third power. The next example is 63. I know that 7 times 9 is 63 because it's a multiplication fact, but I could also use the divisibility rules. 7 is a prime number and cannot be broken down any further, so I'm going to circle the 7. The 9 is composite and can be broken down into 3 times 3. 3 is a prime number, so I'm going to circle both 3's. 3 times 3 times 7 is 63. I can simplify this with exponents. 3 times 3 is the same thing as 3 squared, or 3 with an exponent of 2. I have a final answer of 3 to the power of 2 times 7. Try out the last example on your own. Once you finish, check this with a nearby partner to see if you got the same result. If you didn't, then you need to work together to fix your notes. Pause the video to complete this problem, then come back. Don't forget to go to the table of contents and write the page number and the title of this notebook entry.